In this lesson we will be discussing the atom and matter. All matter is basically electrical in nature. Any piece of matter is comprised of an extremely large amount of charged particles. In most cases, the different charges, positive and negative, balance each other, making the matter electrically neutral. If we divide a substance, say pure water, into continuously smaller amounts, we arrive at the smallest quantity that still retains the property of the substance. We thus obtain a molecule. Individual particles that comprise a molecule are called atoms. An atom is the smallest particle of an element that retains all the characteristic properties of that element. Hydrogen and oxygen atoms combine to make water molecules. The individual substances, hydrogen and oxygen, are called elements, and substances such as water that are made up of these elements are called compounds. Let's begin our discussion of atoms with hydrogen, the most basic atom. All atoms consist of a nucleus around which electrons revolve in a manner similar to that in which the planets of our solar system follow orbits around the Sun. Most of the mass of an atom is in its nucleus. The nucleus of a hydrogen atom consists of only one proton and is orbited by only one electron. The electron is negatively charged and the proton is positively charged. To account for the atomic weights of the elements, all nuclei except hydrogen possess additional particles that are neutral in charge. These particles are called neutrons. The arrangement of elements according to their atomic structure is indicated in what is called the periodic table. Each element in the periodic table has two numbers associated with it, the atomic number and the atomic weight. The atomic number is the number of protons in the nucleus, while the atomic weight takes into account the number of neutrons also. The number of protons in an atom is equal to the number of electrons. Let's look at an example. The atomic number of uranium is 92 and its atomic weight is 238. Because the number of electrons equals the number of protons, the uranium atom must have 92 electrons. If its atomic weight is 238 and there are 92 electrons, there must therefore be 146 neutrons. The electron and proton are attracted to one another by what is known as electric force. Electrons possess a negative electrical charge, while protons possess a positive electrical charge. Because this force of attraction exists between the nucleus and the electron, and in order for the electron to maintain a fixed orbit, it must move at a constant velocity in its orbit to develop the centrifugal force needed to balance this attraction. The orbiting electron possesses a certain energy level due to its velocity. The greater the radius of the electron orbit, the greater the velocity must be, and therefore the energy of the electron to keep it in orbit. Therefore, the lowest energy level in an atom is the electron orbit closest to the nucleus. As the complexity of atoms increases, the number of electrons and protons also increases. Atoms of higher elements have their electrons arranged in different orbits or energy levels called shells. These shells are denoted by the designation K, L, M, N, O, P, and Q. In any one shell, a certain maximum number of electrons may exist depending on the shell. Also, within a shell, subshells may exist. These subshells are designated as S, P, D, and F. The table shown indicates the maximum number of electrons in each shell and subshell. In considering electricity as an energy-conveying medium, we need consider only those electrons in the highest occupied energy level of the shell structure of a particular atom. These electrons are called valence electrons. The number of valence electrons possessed by an atom governs the manner in which atoms will combine chemically to form stable molecules. An atom is most stable when the highest occupied shell or subshell is filled with the limit of electrons. Elements that fall under this condition are called inert. Helium and neon are examples of inert elements. There are many elements, however, that are a few electrons short or a few electrons in excess of a complete subshell. They tend to combine with other elements in a manner that will permit all atoms in a molecule of a compound to have completely filled subshells. This is called atomic bonding. An atom that either loses or gains electrons in the bonding process no longer has the exact same chemical properties as the neutral atom and is called an ion. When an atom gives up an electron, it becomes a positive ion. It now has more protons than electrons. And when an atom gains an electron, it becomes a negative ion. It now has more electrons than protons. There are three types of atomic bonding that will achieve this requirement: ionic bonding, covalent bonding, and metallic bonding. For purposes of our discussion of electrical conductors, we will only discuss metallic bonding. In certain metals, such as copper, the outer shell of the atom contains only one electron. Since the copper atom would be more stable without this electron, only a very weak attraction keeps it in orbit around the nucleus. The copper atoms donate their valence electrons to form a vast cloud of free electrons, thus becoming stable positive copper ions. The atoms are held together to form a solid metallic form by the attraction of the positive metal ions and the cloud of free electrons. This is called metallic bonding. In a copper conductor, the free electrons form the energy conveying medium, which is the equivalent of the hydraulic fluid in our earlier analogy. To be suitable as an electric conductor, a material must possess a large number of free electrons. Conversely, an ideal insulator has no free electrons.